And what I'm going to be doing is, again, starting off with some basic division concepts. So yesterday, if you guys remember, we talked about kind of the different ways you can divide. So different ways of dividing. And so yesterday, I think kind of the breakdown that I gave might have been like a little bit confusing, but I hope that today kind of clarifies that a little bit more. So I found like a different method of teaching this, so hopefully this like makes long division much more easier. But let's start off with the example of us doing 2 divided by 528. So for now, we're doing a 3 by 1 division. So when we're looking at this number, you can think of it in terms of grouping. So we have a 1-digit number that's being divided by a 3-digit number. So in these cases, what we're going to do is actually focus on looking at this number, like this huge number, 528, one at a time. And the reason that we're choosing to look at it like individual digit by digit, so like 5, then 2, then 8, is because we actually only are dividing by like 1 digit. So I'll show you what I mean. So because we're dividing 528 by 2, what we're going to be doing is actually looking at first the 5 digit. So this means when we start dividing this number, we're only looking at 5 to start with. So we have to think, how many times can 2 go into 5? Well, we know that 2 can go into 5 like 2 times, right? Because 2 times 2 is 4. So we put a 4 there. Then we just subtract it, right? We can bring down our 1. And now we can bring down the 2 from over here. So now we have to think, okay, how many times does 2 go into 12? Well, that's 6 times. And that's pretty easy for us because we can see that it's an even number. So again, we put down 6, 12. So now we can bring down a 0 from here, and we can bring down all the way our 8. Okay? So how many times can 2 go into 8? That's 4 times, and that's it. So pretty simple. In this case, we're not doing any remainders. We're not doing any of those decimals that we did yesterday. We're just going like step by step, continuing to make it a little bit more complicated. So this is one of the first kind of example questions. Like we do a 3 by 1 kind of division. And the next one that we're going to do is, again, another 3 by 1. But this is like kind of a special case because this time we're actually going to be grouping it in different ways. So if you think about it, if we still continue to try to do like the 1-digit way, where we only look at the 5 and we only look at the 8, we realize like immediately that 8 can't go into 5 like multiple times because 5 is less than 8. So we only have to multiply, we're only going to look at like this group of numbers, so 52, not just 5, and then use that to come up with how many times can 8 go into 52. So in this case, 8 can go into 52 like 6 times if you remember your 8's tables. So then that would be 48 and subtract. And when we subtract, we again bring down the 4 because 52 minus 48 is 4, and we can bring down our 8. And again, we're looking at it in terms of like groupings of 2. And so how many times can 8 go into 48? Well, that's 6 times. Now I want you guys to kind of like notice this pattern. Like the reason why I'm even showing these example problems in the first place is it's still like a 1 by 3 division. There's not that much difference between it, but you can see like the amount of steps that's being taken. So this is like 1 step, and then this is like the 2nd step, and then when we had to like subtract it again by 8 to get like our 4 over here, that's the 3rd step. But in this case, when we did 528 divided by 8, we only had 2 steps. And the reason for like the difference in number of steps is just basically because how we're grouping these numbers together. In the 528 case, when we divided by 2, we were looking at it like basically digit by digit because 2 can go into 5. But in the 528 example, we were only looking at like the first 2 digits because 8 can only go into 52, but 8 cannot go into 5. So this is just some kind of like a kind of pattern that I hope you guys realize, and it's something that's like kind of consistent within long division, which is basically the idea that you want to create like bigger chunks of the numbers. So whenever we're going to divide something, you can look at it as an entire number. Like for example, when we divide anything by 528, so like any number x, you can either look at it the first number. So when you're trying to figure out like what this number is going to be, you can only look at it like just by looking at 5. Or you can look at the entire number as like 52, or even like the biggest part of it as 528. And all of these methods are correct. It's just which one's like the easiest for you guys. when it comes to actually looking at whatever this number x is. So just being like smart about how far you're going to create like these chunks is going to be important when it comes to like dividing as easily as possible. So I hope that little explanation is good. We're going to keep on talking about division. I just want to check if we have any questions before we continue on. But this is like a basic introduction to like how are we going to do division in this case. Like what do I mean when yesterday we were talking about like sometimes we chose only like the first number, but sometimes we went all the way to like the second number. And that difference again has to do with whatever this value of x is and how many times you can put x into that value. So I'm going to give another example. And this time what we're going to do is actually focus on not 2 by a big number anymore, but we're going to be looking at dividing by a 2-digit number. So in this case, we did like 2 divided by 528 and 8 divided by 528. This time, let's try 24 divided by 528. So 24 divided by 528. So when we're looking at this number, again, like you have to see how many times can 24 go into it. Well, 24 can definitely not go into 5, like anytime. So we are going to expand it to go into like 52. And we can know that like 24 will go into 52 2 times, because 24 times 2 is 48, but 24 times 3 is 72. So again, 3 is too big, so we just focus on the 2 part. So we subtract it by 48, so we're left with 48 again. And the kind of neat thing is that like now you have 48 showing up again, and you already know what that is. So again, it's just another 2. So it becomes 0. But one thing I want you guys to kind of note is like whenever we take in more numbers, again, we're taking in less steps. So this is just 1 step, and this is 2 steps, instead of like having 3, 4, 5 steps, because you're using bigger chunks of this original number. Additionally, even this like final quotient, like your final answer, is also smaller. So compare it to the first time that we divided by like 2, for example, we get a 3-digit number like 264. But when we divided by 8 and 24, we got like a 2-digit number like 66 and 22. And again, that's because we're using less steps, and then also we're using bigger chunks of the number. So the number that comes out at the end will also be like kind of smaller, if you can think of that like intuitively. So even before you actually answer your question, you can kind of tell how big your final result is even going to be by just realizing how many chunks of the number you're going to be using. Now, like for the final example with these kinds of things, is we're going to be trying to, again, divide by 28. But this time, we're going to be dividing by 28 by 88. So there, new slide. I hope, yeah, okay. So 528 divided by 88. In this case, you might be thinking again, like, okay, how many times can 88 go into 52? Well, this time we know that 88 can't go into 52 because 52 is smaller than 88. So we're going into having like the biggest chunk. So we're going to take in all 3 numbers. And this kind of division can get difficult, obviously. So when we're looking at these numbers, what we can actually do is trying to round it. We're going to try to round it into something that makes it look a lot nicer and a lot cleaner. So what we can do is actually use estimates. So in this case, I'm going to try to show you like a little trick. Hopefully this makes like these divisions of like more complicated numbers, like numbers where you probably don't know like the times tables too, a little bit easier. So when it comes to things like where you take bigger chunks of the numbers and you don't really know the times tables for it, you can make 88 into the kind of closest tens value it has. So 88 is like 2 away from 90, so you can kind of round up 88 into 90. And then 528, you can round it down into the closest 100 places that it is. So you can estimate that to be around 500. And when you do these estimations, now you can think of it as like dividing 90 by 500 instead of dividing 88 by 528. And in this case, we kind of have a more intuitive sense. So this is something that we were talking about yesterday, like where all of these extra zeros don't really mean anything. You can worry about that later, just focus on the number itself. So these numbers itself, we know that 9 can go into like 50, for example, like 5 times, right? Because 9 times 5 is 45. So we know that we're going to get around like a value of 5 if we're going to divide 90 by 500. Of course, that would get you like a remainder of 50, but you don't have to worry about the remainder now. Again, this is all just estimating. If you even want to like pull the estimation further, you can even think of it as like 100 divided by 500, and that still would be the same kind of estimation, because you'd still get this kind of like at least value of 5. Now, the reason why we're even estimating in the first place is kind of like what I was saying yesterday, when we don't really know like what the times tables is for 88. So instead, we're going to try to find like the closest values that can get us to like 528. And since we estimated that 88 is close to 90 and 528 is close to 500, then we can kind of like try to guess and say like maybe 88 can go into 528 like 5 times, right? Because we constantly see this kind of estimation shown up. So I'll erase this. So now let's actually like test if that kind of estimation was correct. So what we do is, again, like the normal way that we'd usually be dividing. So we have to like actually multiply out 88 by 5. And so you can think about the trick that we learned yesterday, where it's 5 times 80 plus 8 instead of just 5 times 88. And this is the distributive property again. So you distribute the 5 into it. So 5 times 80 is 400. 5 times 8 is 40. So it'd be 440. So then you could subtract this 528 from 440. And when you get that answer, what you're actually going to find out is that the result would be, I'm pretty sure, yeah, is 88. So this kind of tells us that we were actually really close with our estimate, because this extra 88 is like exactly the same thing as like putting in 8 into 88 like one more time, right? It's like multiplying it by 1. So all you're basically missing is just multiplying like your 88 instead of like by 5, it'd be by 6. Yeah, somebody else wrote that. Good job. So that's why like looking at the estimations can be kind of helpful, because in this case it wasn't 5, but it was really close to getting us to 5. So this is like what kind of answer you would see in this case. So like yesterday there were a couple of questions about whenever you try to like expand, like doing these kinds of divisions, somebody did say like these numbers get like really complicated and it gets like so much harder to write out these kinds of equations, right? Like because you have to keep on like guessing what this 5 is going to be, or kind of guessing like how many times you have to put in 88 to 528. But instead of like just trying to randomly guess, I hope this kind of form of estimation where you can try to bring the numbers closer into like the zeros value, so like 88 closer to 90 and 528 closer to 500, and use those estimations to kind of help you gauge where that number is going to be. Of course, this example was kind of like neat and clean, like 88 could go into 528 6 times, and the examples that we did yesterday did have like remainders, but the same kind of like idea of like looking at bigger chunks, noticing like how many steps are being taken when you look at bigger chunks of the numbers, and then also using these estimation formulas can be helpful whenever you do like any kind of division problem.